Hello, everybody. I'm Andrei, and I work for JetBrains as a Senior Vice President of Investments, Research, and Education. Welcome to Regionals. Great things happen when great minds come together. JetBrains wants to seek out great minds all across the globe, support their initiatives, and work together to create great things that will make the world a better place. That's why JetBrains is proud to be a Global Tools sponsor of the ICPC. There are already many great minds working at JetBrains, and together we have created some amazing things, like the Kotlin programming language, for example. It keeps on growing and growing in popularity. In 2017, Google began officially supporting Kotlin as a language for writing Android applications. We have also created professional development tools like Cline for C++ programmers, IntelliJ IDEA for Java, PyCharm for Python, and also educational tools that help people learn and teach programming. The regionals are the biggest contest in the ICPC calendar. Thousands of talented people all over the world team up to solve complex real-world challenges. These contests are the proving ground for future champions. But even if you don't make it through to the finals, the experience of competing in the regionals and the new friends you'll make along the way are priceless. Enjoy the ride. Best of luck to everyone.
So the next problem is peace, freedom, justice, and security. And where 137 accepted solution, it was a geometry problem. And thanks, Kevin, for Kevin or the author for that. And explanation would be given by Ajinkya.
Yeah. So before we begin, firstly, let's quickly look at what the problem was. So we were to find 3 points P, B, T, such that each of those points were some lattice points. That is, they had integer coordinates, and the pairwise Manhattan distance between each of them should be the ones that were given to us in the problem statement. So we were firstly, we had to decide if we could find such points, and if yes, we had to actually find those points. So before we begin, first let's try to see the cases where it is not possible to find any of such points. So as we can see here, firstly, if the distance from say P to B and the distance from B to T, if their sum is less than the distance from T to P, then this actually means that the distance from T to P is actually larger than the distance via a different route through P, and that is actually not possible, right? So for such cases, we would say that it's impossible to find an answer. Another one is a case where the sum of these distances is odd. And again, this is equivalent to starting from a point, say P, going through different routes, firstly to point P and then T, and then returning to P. And if we consider this as a walk along the grids, then we are just walking through the grid and then coming back to the same point that we started to. So again, this can only be achieved in an even number of steps. So again, if the sum is odd, then we can say that it is impossible to form such a triangle. So if we don't have any of these cases, we can try to find if a triangle is possible. And we say that it is always possible. Let's try to see how in the next slide, please. So as we try to reach to a solution, let's try to find some insight so that the solution is simplified. So firstly, we will begin by assuming that one of the points of the triangle is at the origin. And again, we can always start with this assumption, because at the end, we will just translate whatever triangle we get to the first quadrant, because that was another constraint in the problem, that all the coordinates should be in the range from 1 to 10 raised to 9. So we can just begin with the assumption that our triangle, one of the points of our triangles is at the origin, and then we will translate it to the first quadrant. And while we are assuming that, for our convenience, we can also allow negative coordinates if that help us in getting any of the triangles. So with this in mind, let's also move on. So yeah, we have already fixed one of the points at the origin. Let's also try to see if we can fix another point. So we state that if an answer exists, we can always say that there exists a triangle where two of the points are aligned either horizontally or vertically. That is, one of the sides should be parallel to the x or the y axis. And suppose it is aligned vertically, we can always rotate it again so that it becomes aligned horizontally. So we can also say that there is always an answer where the side of a triangle is aligned horizontally. And again, if that is true, so there will exist a side with coordinates 0, 0 and x, 0. We can also assume that x is greater than 0, because if it's not, we can just flip the triangle horizontally. So yeah, this sounds not very intuitive maybe. So let's try to formally prove this as well. So can we move on to the next slide, please? So yeah, let's try to prove why it is always possible to have a triangle where one of the sides is aligned to the horizontal axis. So suppose that's not the case, and we have a triangle which satisfies all our constraints in the problem statement. And let's try to consider a point. Let's rotate the triangle such that there is a point xy, which is the leftmost bottommost point of the triangle. Or in other words, both the x and y coordinates are the lowest for that point. And again, it will always be possible because there are only 3 points that we have to consider. So suppose we have rotated the triangle now and we have such a point xy. So the area of this triangle can be said to be alpha x plus beta y. And these alpha and beta are actually just dependent on the 2 points, the 2 other points of the triangle. And this can be said via the shoelace formula, which helps us to find the area of any polygon in the Cartesian plane. So if the 2 points are fixed, this area is just dependent on the leftmost bottommost point xy, and some other parameters that are dependent on the other 2 points. So yeah, let's move on. So yeah, since the area was alpha x plus beta y, and remember that xy was the leftmost bottommost point of our triangle. So if x comma y is not yet aligned either vertically or horizontally to the other 2 points, we can always try to move this point in any of these 2 directions, where we either try to increase the x coordinate by 1 and decrease the y coordinate by 1, or decrease the x coordinate by 1 and increase the y coordinate by 1. So by doing so, the area will either increase or decrease by alpha minus beta, as we can see here. So in at least one of the direction, the area will either increase or remain the same based on what the alpha and beta values are. So it's always possible to go in either of these 2 directions such that the area is either increasing or remaining the same. And we can continue to do this as long as one of the sides does not become aligned to either the x or the y axis. Can we move on to the next slide? So yeah, we will continue to do that, and we will go in the direction where the area increases if that's possible, or it remains the same, but we will continue to do that as long as the 2 points are not aligned. So at the end, we will always reach a point where one of the sides is parallel to the x or the y axis. So just summarizing the whole thing, we had already fixed one of the points at the origin, and we also have proved that there is always a triangle where one of the sides will be parallel to the x-axis. So the next point can also be fixed at x, 0, where x is any one of the distances which were given to us. So yeah, let's move on to the next slide. So yeah, as 2 points are already fixed, we are now trying to search for the third point. And yeah, as we can see here, if the third point is moving along some line, this will mean that the height or the altitude of this triangle will also increase linearly. So what we want to do is, the eventual aim is, if there are multiple answers for this, we have to find the triangle with the maximum area. So yeah, that is also one of the points that we'll have to consider. Can we move on to the next slide? So yeah, now the 2 points are fixed, 0, 0, x, 0, and we have all the 3 distances that we want to achieve. So there are some equations to solve, and we can get the 3rd point through that in constant time. Again, if there are multiple options, we will choose the one with the highest y coordinate, because that's what will give us the maximum area. So yeah, the only important point that we needs to be considered while implementing this is that the order of the points also matters, because the problem specifically asks that the distance between those points needs to be what it asks for. So yeah, while printing the points, we need to take care that we are printing them in the correct order. So yeah, basically that was it for this problem.